Ah yes, the Mesozoic era. Back when the biggest continent was Pangaea, and this lovely Brachiosaurus feasted on the wild grass that coated Earth 66 million years ago. And here we have the asteroid that caused mass extinction, wiping out our lovely little friend here. Or so we think. While our friend Bronchi is already dead for a fact, many believe that popular presumptions made about the extinction of dinosaurs are just guesses that can never be proven. But the notion of gravity can't be disputed because it's a law.
This is because a theory is a heavily tried and true law that has been accepted by the scientific community as nearly fact. A theory is nothing without its hypothesis, though, just like peanut butter and jelly. A hypothesis makes an educated guess based on a tentative observation that can be tested or altered until it is true. To dig deeper into these two concepts, let's talk about scientific theory and the correlation it has to its hypothesis. Just because theories seem cut and dry does not mean that they stop evolving through the hypothesis that started them. Let's take, for example, Isaac Newton. Someone who inspired him to seek out the laws of motion was the German astronomer Johannes Kepler. His boss, Tycho Brahe, instructed him to prove that the motion of Mars is circular. Brahe's data contradicted his hypothesis despite his efforts, but he wouldn't change it. The leading ideology at the time was that the Earth was the center of the universe, and he was determined to prove this true. However, the problem was that he changed his data, not his hypothesis, so he never proved anything. However, Kepler recorded his own data and altered the hypothesis he was tasked to prove. What if the Earth wasn't the center of the universe? What if Mars had an elliptical orbit? This led to an amazing discovery that changed the world of physics. By plotting the positions of the planets in comparison to the Sun, he noticed that they orbited faster when they were closer to the Sun. When a triangle is drawn from the Sun to a planet's position, the area of the triangle is always the same, regardless of where it is. For this to be true, it would be impossible for the orbit to be circular. It had to be elliptical. He defied the notion that the Earth was the center of the universe, and that perfect circles existed. He accomplished this by creating a new hypothesis and therefore solidifying his theory into law. Because of this, Isaac Newton was so inspired it led to the creation of the laws of motion. We all know about the folklore about the apple falling down a tree and how that sparked Isaac Newton's thoughts on gravity. What we don't know is about how this law has evolved over time. For example, how would you measure gravity? An important step in the creation of a law is how to measure it. A hypothesis allows us to figure out ways to measure concepts like the speed of light or the force of gravity. Thus, units like light years for time and space and newtons for forces came to be. Without them, we wouldn't be able to define laws or theories. Now that we know their definitions, how does a scientific theory relate to our research hypothesis? Well, we can say an apple falls from a tree. Our hypothesis would be that some sort of force made that apple fall. Carrying out our tests, we conclude that a force called gravity acted upon a still subject and made it move. After testing this on different objects and observing it over and over again, we can now declare this to be a theory. In Newton's case, he noticed that gravity had different effects on motion. Thus, he differentiated these theories into laws, all encompassed within the laws of motion. Science is always changing, not our physical world, but how we interpret this world. There are still phenomena that need explaining, and theories that need explanation. And it's always important for us to remember the concepts that continue to explain the world that we live in, even if it starts with a simple observation.
So let's put our skills to the test. Let's say that you lost your pencil. You have to figure out where you last left it. Which of these would be considered a hypothesis? A. I left it at the library. B. Thomas told me he has it. C. Both A and B. C is the correct answer. If you left it at the library, you would need to check, regardless if you find it or not. It is still a hypothesis, even if you need to change it. If Thomas told you he has it, then you would need to see if Thomas actually has your pencil or not. Good job! So, turns out Thomas didn't have your pencil. Now the only option left is to check the library. Does this turn it into a theory? A. Yes. B. No. Yeah, that's a theory. There's no other way to explain what happened to your pencil. If you found it, then your theory is correct. If you didn't find it, then we need to work on that hypothesis that we started with.
Thanks for watching the video. Make sure to check out the other videos and have an awesome day.